Hi, welcome to this lesson on calculus, applications of the first derivative. Let's have a look at question 5. We're given a rough sketch below. Determine any stationary points and intervals of the function f where it is increasing or decreasing. Okay, so this function here, which looks like it's a quadratic or parabola, is the function f, and we're given some points on the graph. We're given the two intercepts, so here's 3, 0 and negative 1, 0. And we're given a y-intercept of 0, 6, right? So this is turning point here. Well, we can actually work that out, right? The turning point, because of the symmetry of a parabola, the turning point, the x-coordinate, must lie halfway between negative 1 and 3. So if I find the midpoint of that x, so that x midpoint will be 3 plus negative 1 divided by 2. That's 2 divided by 2, which is 1. So at x equals 1, that should be the x value of the turning point. Okay, can I find the potential y value? Well, yeah, let's think about it. We know the shape of the graph, so therefore the function value f of x is most likely going to look like this. If I try to put it in vertex form, for the completed square, it's going to be a times x minus p all squared plus q. We've got our p value already. Our p is 1. So if we can find q, then we've got the whole graph. But look at a as well, right? A now is going to be negative because it has that following shape, a sad face, or the maximum turning point. Okay, and we have a value to work off of. So if I go f of 0, so at x equals 0, the y value should be 6. So it's going to be a times 0 minus 1 all squared plus q. And that must equal 6. So now I have a times negative 1 squared plus q, which is going to be negative 1 squared is positive 1, so a plus q, and that must equal 6. So let's call that equation 1. That's definitely going to come in handy. Okay, do I have any other points I can substitute? Well, yeah, I got negative 1, 0, and 3, 0. So let's do f of 3. Okay, so that's going to be, again, a times 3 minus 1 all squared plus q, and the y value must be 0 at that point. So therefore I have 3 minus 1 is 2. 2 squared is 4. So I have 4a plus q equals 0. Let's call that equation 2. So now look at this. I have two equations in two unknowns, a and q, so I can solve these simultaneously. So let's go ahead and do that on the left-hand side here. So I have a plus q equals 6, and then I have 4a plus q equals 0. So what I'm going to do, because they each have a q, I'm going to subtract them from each other. So I'm going to say equation 1 minus equation 2. So a minus 4a is negative 3a. Q minus q is 0, and then 6 minus 0 is 6. So dividing both sides by negative 3, I therefore get that a must be negative 2, which makes sense. We said our a value must be negative because of the shape. So now that we have that, we can substitute it back. So f of x equals negative 2 times x minus 1 all squared plus q. Okay, and now to find q, again, we can just come back to this original simultaneous equations we worked with. Since a is negative 2, so I'll work with equation 1. So I have negative 2 plus q equals 6. Then if I take negative 2 on both sides, I add it, then I get q equals 8. That's plus 8. So because I have it in vertex form now, the completed square form, I know my q value is that y value of the turning point. Okay, so it's really important that when we do any questions that involve functions, we are very well versed and our function fluency is there. All right. Okay, now I feel like I've got all the information I need because now I can determine stationary points. So that's when the first derivative is equal to 0. Now that I've got the function, I can expand this function out. So it'll be negative 2 times. It's going to be x squared minus 2x plus 1. So that's squaring out x minus 1 all squared plus 8. So expanding that out, negative 2x squared. Negative 2 times negative 2x is positive 4x. So be careful when you expand out. And negative 2 times 1, and then plus 8. So I get negative 2x squared plus 4x plus 6. So for stationary points, you set the first derivative equals to 0. But the first derivative now, if I do the power rule on this function, that's going to be negative 4x plus 4 equals 0. Okay, I can take 4x across, so it's 4x equals 4. Therefore, x equals 1. And that's what we kind of expected. The turning point is where the gradient of the tangent line will be 0. Okay, but the gradient there is f prime at x. Okay, so that is a stationary point. What about intervals of increasing and decreasing? Okay, so for increasing, we say that is when your f prime of x is greater than 0. So again, that's a linear inequality. Negative 4x plus 4 is greater than 0. I can take 4x across, so I'll have 4 greater than 4x. But to see what that looks like the other way around is if you're holding a mirror, that's the same thing as saying 4x is less than 4. Okay, and if I divide both sides by positive 4, I'm not changing the inequality sign. That's x less than 1, where x is a real number. So in interval notation, that is just x from negative infinity to positive 1. That's where your graph increases. And then again, if we apply that same logic for decreasing, we will get the following interval. That's when x is from 1 to infinity. And we can see that. Here's the graph decreasing from the turning point. And then from the left of the turning point, we can see the graph is increasing from the tangent lines. Okay, so again, very nice question, very visual. From the visuals, we took that and applied our function knowledge to get the equation of the function. And then from there, we were able to use our differential calculus techniques to find the given information that we needed. Awesome. I'll see you in the next one.